Hi everyone, so I get myself a new printer, a Creality K2 Plus, a $1900 a 3D printer, and it weighs about 50 kilograms. This printer will replace the K1 Max that I've been using over a year. Okay, look at the quality of the first layer, it's very good. So only one mod that I have made so far is adding the foam pad on the side of the printer because the belt here is clashing and it's make a loud noise. So if you look at the back side of the K2 Plus, there's going to be a waste chute exit port here, but it doesn't come with the collector like a plastic bin. It will shoot out this little poop in the back of the machine against the wall. So in this video, I'm going to make a chute rail from this point and down to this point on the tabletop. There's two mounting screws here, but I'm not going to use it because it's self-tapping screw. The female thread is plastic, so I don't want to take it off and put it back on. If you do this several times, it's going to strip the threads. So I will use double-sided adhesive tape for mounting this. So the temperature near the heating fan is about 53 degrees Celsius. And near the waste chute about 65, because now I'm printing with ABS. Now it's above 65 degrees. So I recommend that you should use ABS or a PETG. And this should be enough. So the scanner that I'm going to use today is the Creality Raptor X for scanning. Creality K2 Plus, a flagship scanner, is going to scan flagship printer. And I'll use my gaming laptop here. I choose 0.3 for the resolution. Let's fuse the point cloud, 0.3mm. Remove the marker, click here. Okay, here's a scanning result from the Raptor X. Next, I'm going to export this as a point cloud. Okay, this is cloud compare. I'm gonna bring in the point cloud for alignment. Okay, I will align this panel to the XY plane. I click on 3 point, 1, 2, and 3 because it's a flat plane. Next, I'm going to align it to the X or Y axis. Gonna rotate it using the edge of my monitor to align it. So now it's aligned to the X axis. Next, I'm going to move the cornea to the origin point. Now it's already in the origin point. Next, I'm going to change the color. This is very important because Autodesk Inventor, you can't change the color later. Alright, now it's ready for reversing with the Autodesk Inventor. Okay, here's in Autodesk Inventor. This is the waist chute that I designed by using the point cloud as a reference. So my concept is that the tube has to be larger than the exit from the printer. The exit from the printer is 4 by 4 centimeters. So if I measure from this side to this side, it's about 42 millimeters. The one that I made is larger. So poop that come out from the printer should be less than 4 centimeters. That's why the manufacturer, they designed the exit to be 4 centimeters. And the second part, I will be using the panel screw because it is a self-tapping screw. So it's not meant to be used for mounting the waist chute. The waist chute is between the two fans. On the left is exhaust fan, and in the middle is the inlet fan for the heater. So I'll try not to block these two fans. So I spaced the tip from the panel for 15 millimeters. I found that mechanical fan this size, if you have space about 15 millimeters, it won't be blocking or give a resistance to the airflow. This will be mounting point, 3 points in total. So I divide the tube into 2 parts. Because it's too long to print in just one single print, so I divide it into 2 parts. The smaller one, the first one, we have only 1 mounting point. So these two tube is overlap. One is bigger than the other, just a little bit. Overlap about 8 millimeters. And this tube will go around the corner of the printer. Waste should be falling into this cup basket. The angle here is 60 degrees. If I put it to 45, the basket will be much shorter. So I think 60 would be enough for making the waste falling into the basket. Okay, here's my workflow for designing this part. First step, I will create a sketch. I intend that the wall thickness of the tube will be 2.4 millimeters. Printing with the ABS, I think 2.4 would be quite enough, not too thin, not too thick, a little bit larger than the exit hole from the printer. And I create this sketch by snapping it on the plane using the point cloud as a reference, the back panel plane. Here's the plane. And then I extrude it like a box for 5 centimeters because I noticed that when the printer ejects the waste, it will fly out in the horizontal direction. So I need some space so that the waste won't be knocking on the wall and bounce back inside the printer. So 5 centimeters would be enough, I think. Okay, next step, I create a plane here, horizontal to the table. This plane is perpendicular to the panel as well. The size of the square box here is 43 by 43. So I choose the minimum size for the tube for 4 centimeters. The largest poop will be able to pass onto this channel, and I arrange it manually so that it will be positioned here a little bit to the right and 15 millimeters from the panel. Okay, next I choose the loft command to loft these two faces together. And then I create a second sketch, making an angle to the first sketch 60 degrees. So I can always come back and adjust this angle. First time I choose 45. If I choose 45, the tube will be too low and closer to the table. So I think 60 would be enough, and it should be fall easily. The waste should be fall to the box easily. I create a sketch with the same size of the box, and then I loft it for the second time, so it looks like a pyramid shape. Okay, next I create a sketch here and extrude it for 10 millimeters. So we have this shape now. So next step, I'm going to create a fillet on the 4 corners because we are going to print in this direction. This side will be facing the print bed, and this side will go up. So the wall line will be running along this, and you should create a fillet so that the print head will move smoothly without a sharp corner. So fillet is quite good when you use it parallel to the wall, so it can improve the printing speed. Okay, next I make a chamfer here for 2 millimeters, so it won't be too sharp. Okay, next command, I use the shell command to make it hollow, and I remove this face and this face. So two faces removed. Now we have a hollow tube and shaped like this, the one I just made. And I made one cut here. Because of a thickness function, the wall is aligned in one angle, so I need to cut it open. So it's lower, see here, this one will be lower than the exit from the printer. So there's nothing is blocking the waste from going back inside the printer. Okay, next I'm going to create a mounting point here for the first tube. The mounting point will be between these two fans. And the size is 12. 12 is the width of 3M VHB tape, and the length is 3 centimeters. And then I extrude it to this face of the part, so it's create a wedge shape. And then I offset for the thickness. I use direct move function to move the face back about 1 millimeter to compensate for the thickness of the double side tape. So you need to use double side tape that is thicker than 1 millimeter, 1.2. So if it's thinner than this, this face will crashing with the panel before the adhesive tape. So keep that in mind. 3M VHB, the white color tape, that one can fit into this. I'm not sure about the red one. Okay, so we finished the first part. I'm going to the second part. Okay, to create a second part, I project the profiles from the first part. And this yellow outer line is from the first part. And then I extrude it for 190 millimeters. So it's just passing the body of the printer. If you look from the top, see here. And then I do the same. I make a turning angle. I think it's 45 or 60 degrees. I can't remember. Let me check. Yeah, it's 45 degrees. I create a plane 45 degrees from this plane. I then create this sketch which has the same profiles. And then I loft it to make a turning angle. And then I create this sketch, just project from the last profiles. And then I extrude it for 8 centimeters. So it's now reaching the basket. I draw the basket, the last object. So I draw the tube first and then the basket layer, so I can find the height of the basket. Okay, next I create a fillet here to make turning smoother, so when it fall, we hit a curve or something, not sharp corner. Okay, next I create a new sketch on the starting point, larger than the original one by 3 millimeters, and then I extrude it for 8 millimeters. So we have a two-step of the body. This one is larger to create a flank. So we have a flank for mounting onto the first tube. I create a chamfer. So when I print, because I'm going to print in this direction, it will go up smoothly. Okay, next I create a shell, same command, using 2.4 as a thickness. So this solid block will turn into a tube, hollow tube, 2.4 millimeter thick wall. So I create a sketch here for cutting this profiles. So here I cut it so that it will give at the end of the tube it will look smaller and less aggressive. Okay, next step I create a mounting point, the same as the first part, drawing two rectangles 12 by 30, and I find a space in the center of the tube, create it on the plane of the back cover lid, and then I extrude it. And then I create a chamfer so that when I print in this direction, this chamfer will, so I don't need to use a support for this. But if I don't have a chamfer apply here, I'm gonna need a support, which is a waste of the material. So if I use a chamfer here, so the filament can climb up. Okay, it's all done for the tube. And for the basket, you can simply use the cardboard from the filament cardboard box to put it here. But if you want to print it, the box with the same size, so just simple function that I use to make this part. Draw a rectangle, and then I extrude it with an angle of 3 degrees, so it looks taper. And then I fillet the four corners to improve the printing speed. And I chamfer the bottom, and then I shell it 2.4 millimeters, remove the top face. And that's it. 3 parts to be print. These 2 parts will be print with the ABS because I think it's going to be over 60 degrees on the back panel here. And for the basket, you can use a PLA or PETG for printing. Alright, let's move to the printing part. Okay, it's a Creality print. I dropped 2 files, part 1 and part 2. For part 1, I'm going to align this face to the print bed, and you should space this to a bit apart because you're gonna need support on this part. Okay, space like this, and then because the first time I sliced it, I put these 2 parts too close together, and the 3 support was eaten into the object. So one part of the base here was cut off by the 3 support. It's because it's placed too close together. Place it like this. So let's slice it. Before that, enable support. I choose CIBS. Okay. So this part, the longer one, does not require any support. See here, 0 support. But this part, unfortunately, the first one requires support. But I don't think it's difficult to remove. And you should space this to object a few centimeters away, because when you print it, don't put it too close. So the printing time will be 6 hours and 167 grams of the filament. I put the download link in the description so that you can print this yourself, and also the point cloud in case you want to design your own poop chute or the K2 Plus. Alright, I send this to the printer and see how it fit and how it performed. Okay, the print has finished about 5.5 hours. Let's remove from the printer so it will cool faster. Okay, so just come off like that. I apply adhesive. Look at the quality of the print. I can see some wrinkling, but there is no C banding. Now, the surface quality is better than the K1 Max. This is a C line. I dry this filament with the Space Pi X4 about 8 hours before I print. There's something wrong with the slicer. The 3 support cut into the printing part. I didn't see that in the slicer. So you should be spacing the 2 parts away from each other. So in assembly, it would be like this. So if I put some poop, it will come out. Yeah. Okay, so I think the poop will go out. Heat resistant. You need to install the first tube first. There's a sticker here. This edge of the tube has to align just under the sticker. Okay, the first part is in, the second part. And for the adhesive, I recommend that you use a 3M VHB. It will have a thickness around 1.1 or 1.2 millimeters. If you use a thinner adhesive than this, it's not going to fit because this part will crash with the panel. So it's quite sturdy. I don't think it will fall even with the high temperature. Just remember to use the VHB, 3M VHB. Next, I'm going to print the basket. Just a simple basket that I made. You can make it your own, but this time I will use PETG to see how well this printer will print with the PETG. Bed temperature 60 to 80, and the nozzles is 220 to 260. Okay, here's the printed basket with a PETG, and it removed from the print bed very easy. When it cooled down, I just pull it off. There is no need to use adhesive for PETG and the ABS for the K2 Plus printer. So if you look at the quality of the print, I still can see the ringing, but the surface is smoother if I print it with the K1 Max. And when I squeeze it, there's no cracking noise. Unlike the ABS, sometimes when you squeeze, when you print a thin wall, and you squeeze it, you're gonna hear cracking noise. I think it's doable. If you're not going to use it in a high temperature area, I think PETG with a high speed, hyper PETG is very good. There's no stringing because it's a new roll. And after this, I have to put it in a dryer because PETG, it absorbs the moisture quite quickly. Okay, so done. You need to keep it in a dryer, otherwise it's going to be strinking. Okay, thanks you guys for watching. I'll see you in the next video.